These are the Mod 4 Part 5 notes, page 1. We are going to talk about standard deviation and the empirical rule. So first off, we are going to start by defining standard deviation using the equation. We're going to take a look at an example of how we find the standard deviation by hand. Most of the time we will do this in Excel, but this example will help you understand a little better what standard deviation means. So back to the beginning, when we're talking about samples, our standard deviation is S. The formula here is the square root of the sum of x sub I minus x bar all squared divided by n minus 1. Now this looks a little overwhelming. As we walk through it below, it's going to make more sense. Remember that sigma means sum. It just means we're adding a whole bunch of things together. The x sub I is an individual data item. Our x bar is the mean of the sample, so it's the average of those x sub i's. Our n is our sample size. Okay. For our population standard deviation, instead of the S, we use the sigma. Again, square root. And this looks the same except for the notation that is now specific to the population instead of the sample. Okay, so let me make this stuff a little smaller so I have room and everything's not running together. So our mu is our population mean. Our n is our population size. Okay, now notice those look exactly the same other than the simples for standard deviation and for mean and the denominators. When we have a sample, we want to account for the fact that we may have chosen a sample where our numbers are going to be a little skewed, may not be completely representative of the population. So we divide by a number that's smaller, which makes our sample standard deviation a little larger. If I'm working with the entire population, I know I've got all of my values accounted for. I am just dividing here by that population size. We are not worried about anything else. Okay? So we are going to crank through an example so you have an understanding of what's going on here, and then we're going to look at how we do this in Excel. So our x sub i's, those are my data values. So the 63, the 88, the 77, and the 68. So that's what I'm going to put here. 63, 88, 77, 68. My sample mean, I find by adding all four of those together. So let me make sure we know where the work is. I got 63 plus 88 plus 77 plus 68 divided by 4. This is how we find the mean. 296 divided by 4. I get 74 is my sample mean, my x bar. So that sample mean is the same for the whole set. Okay. Next thing we are going to look at here is the deviation about the mean. That's this part, x sub I minus x bar. So right now, I am taking care of this part in here. Again, I'm going to write those out. I got 63 minus 74. That gives me a negative 11. I have 88 minus 74. That gives me a 14. 77 minus 74, which gives me a 3. And 68 minus 74, which gives me a negative 6. Now notice, if I add all of these together, negative 11 and negative 6 is negative 17. 14 plus 3 is positive 17. If I add all these together, I get a 0. Okay? Because the question that I usually get is, why do we square all of these and then take the square root? And this is why. When we find the mean, remember that the mean is that balancing point for the set. So I have an equal amount above and below. If I add all of those amounts together, those deviations, I'm going to get 0. So the next thing we do is we square each of these values. That's this part right here. We're going to square those. Okay. Remember, negative 11 squared means negative 11 times negative 11. Anytime you square two numbers, square a number, you get a positive answer. Okay? So this takes care of those positives and negatives canceling out. 3 squared is 9. Negative 6 squared is 36. When I add all those together, I get 362. Okay? That is this part. Oops, sorry, wrong one. The sigma means sum. So when I subtract the mean from each of those data values, square the results, and add them together, I get 362. That is the numerator of the fraction that I have inside that radical. So I'm going to write this out and fill that in here for you. X sub I minus x bar squared over n minus 1. We just found that numerator is 362. My n is 4. I have 4 items in my data set. So that 4 goes right here. 4 minus 1 is 3. I get the square root of 120 and 2/3, if we want to be specific. When I take the square root of that, I get 10.98. So our standard deviation is the average distance of each data value from the mean.